Hey everyone, I want to take a few minutes to go over the problems from class. So if for some reason you missed class or you just needed a quick refresher, this is the place to be. So let's look at problem number 1. It says a person 5 feet tall casts a shadow 8 feet long. A tree casts a shadow 24 feet long. So what is the height of the tree? Okay, so we've been talking about similar triangles. And remember that before we can use the idea of proportions to solve problems, we have to first ensure that we have similar triangles. And there are a few ways we could do it. We could show that corresponding angles were congruent. We could show that corresponding sides are proportional, or a combination of the two, right? We've got corresponding sides proportional with the included angle congruent. So let's look at what we have. We have two triangles here. We have this larger triangle and this smaller triangle. They share an angle right here, so we know that that angle is congruent between our two triangles. And then whenever we're talking about height of something, we always have right angles. So at the tree we have a right angle, and at the person we have a right angle. So there's our other set of angles, the corresponding angles that are congruent. So we have angle-angle congruence for similarity. Okay, now that allows us to set up our proportion. So we've got this this larger triangle and this smaller triangle. We're trying to find the height of the tree, so we'll call that x. And so if we say the side of the larger triangle over the side of the smaller triangle, and then we could say the base of the larger triangle over the base of the smaller triangle. Okay, so you can think of it as height over height equals shadow over shadow, if that kind of helps. Remember, we have to make sure that we set it up as corresponding sides being proportional. And now that we have a proportion, all we need to do is cross multiply to solve it. So that gives us 8x is equal to 120, and if we divide both sides by 8, we end up with x is 15. Now be sure to label whenever you can. We're talking about height, everything else is in feet. Our answer is also going to be in feet. So our answer here is x is 15 feet. Okay, let's go ahead and take a look at the second example. The second example says, given that the following triangles are similar, find the lengths of the missing sides. Okay, so we can tell that they're similar, even though they told us. We can tell because, again, we have these corresponding angles being congruent. And because of that, remember, our sides are proportional. We have two missing values here, so we're going to have to do it as two separate proportions, right? So we'll solve for x first. And we know that this side where x is corresponds to 10, right? They're located in the same parts of the triangle. So we can say x over 10 is going to equal, and now the only other pair of sides that I know is this one, 108. So I'll have 100 over 8. So that's going to give me 8x when I cross multiply is equal to 1,000. And if we divide both sides by 8, we get x is 125. We didn't have any specific unit of measure here, so we can just say 125 units. Okay, and now let's go ahead and look at y. I'll change color here. So now we're going to be solving for y. Again, we're going to set up a proportion. So my side that corresponds to y is that 90. So I'm going to have 90 over y. And again, I'm going to use the 100 and the 8 because I know both of those in my two triangles. So when I cross multiply, I have 100y is equal to 720. And when I go ahead and divide, I end up with y is equal to 7.2. And again, I'm just going to write in units here. Okay, so that's the idea behind that. Let's look at problem number 3. In number 3, we're not actually solving anything, we're just determining if it's possible to prove that the triangles are similar. So remember, we have 3 ways we can do that. We can have angle-angle similarity, we could have side-side-side similarity, or we could have side-angle-side similarity. And so we need to satisfy only one of these conditions in order to determine if the pair of triangles can be proven similar. So if you look at this first pair, you'll notice that we have indications here that we have congruent angles, right? We've got angle C and angle D congruent. We've got angle A and angle E congruent. So we would say yes, that is possible, because remember, if you have two angles congruent, you know that the third ones are also congruent. So you would say yes by angle-angle similarity. And if we look at the next problem, we have two isosceles triangles, right? And what do we know? We've got, if this side is 21, that means this side would have to be 21. And if this side is 7, that means this side has to be 7. So remember, if we have measures of 3 sides, right, but we have to show that not that the sides are congruent, but that the sides are proportional. And we can in fact prove that. We can just say 7 over 21 is equal to 5 over 15, right? 7 over 21 is equal to 5 over 15. And I know that, right, because if I reduce these, I get 1/3 is equal to 1/3. And because of that, my sides are proportional. And so then I can say that the triangles are indeed similar by side-side-side similarity. Hopefully that helps. If you were struggling with any of those problems, please make sure you see me. Otherwise, have a great day. We'll see you next time. Thanks, everyone.